Hi, welcome to Easy Engineering. Today we're going to talk about the importance of laminar flow in blow-off applications, in particular compressed air blow-off products such as the ones I have in my hand. I have three different types of products in my hand. Something called an air amplifier, an air knife, and an engineered nozzle. And in every single case, they work on a very similar principle. You have a small gap, which is maintained by a shim in the air knife situation. You have a small gap in the air amplifier with a shim inside as well, maintain that gap. With the nozzle, you have various holes that are of a specific size to let the compressed air out. But in every single situation, the compressed air is coming out and going off a particular type of surface, which actually draws in air from the surrounding atmosphere. And that air is combined with the exiting compressed air, and it converts it into a much higher flow. What you're doing in every single situation is converting pressure, which is normally lost as pressure drop and noise, into flow. And with these types of devices, if they're properly designed both on the outside shape and the inside, to minimize turbulence, you will end up getting a laminar flow coming out of the unit. Now, turbulent flow. To give you an example of what turbulent flow is versus laminar flow, go to a water tap. Just go to a tap in your home, in the kitchen, the washroom, turn on the tap, put your finger under the water. If you just open the tap slowly, just a little bit, put your finger under the water, and if the water's flowing nice and slowly, that's a laminar flow. You put your finger under that flowing water, you'll feel a force at a fair distance down from the exit of the tap. If you turn on the tap a lot more until the water's kind of spraying out, that's turbulent flow. You put your finger under that spraying water, you're going to feel less of a force, and also it's going to be louder. That's because you're losing energy. So with turbulent flow, you end up with a much weaker force over a shorter distance. It's simply not as efficient. With laminar flow, you get a strong force over a distance, and it's going to be much more efficient in energy saving. So next time you're considering the use of drilled pipe or open tubes, think about the energy and that you're losing in using that kind of a product instead of using an engineered nozzle or an air amplifier or an air knife, because you want to have that laminar flow. It's going to work at a greater distance, which makes it much more flexible in any of your factory operations. So laminar flow, much better to have than turbulent flow. And hopefully this will give you an idea of what to look at as well when you're looking to shop for these engineered products. It's not only just the outside that's important to minimize turbulence, but also the inside. And a properly designed product will minimize turbulence as much as possible.